This tutorial explains how to create a test run configuration. A test run configuration, which I will call a TRC from here on, defines how a performance test executes. To create a new TRC, select the Run Components workspace and expand the Run Configurations node. Before creating a TRC, there are a number of things you should consider. First, you should decide whether the load is to be applied progressively, a ramping test, or whether all load is to be applied immediately, a steady load test. You also need to decide on the user journeys that will participate in your test, the locations from which they should be executed, the distribution of load between the user journeys and locations, and the total load to be applied. Finally, you need to decide which resource monitor metrics will be captured during the test. There are two ways to create a TRC, either using a wizard to guide you through the process or creating the TRC manually. I'm going to use the wizard. To start the wizard, right-click on the application you wish to test and select Run Configuration Wizard. If you have not seen it before, it is advised you read the introduction screen and then click Next. The following screen asks me to provide a name for this TRC. Ideally, this should be a meaningful name, which describes the purpose of the test. I'm going to call my test Ramp Test from London and Boston. Then I select the application this TRC will test. If I wish, I can enter a longer description in the text box. Because I want to apply the load incrementally, I will leave the Ramping Load radio button selected. After clicking Next, I am presented with a list of all the user journeys for the application I selected. I select those that I wish to include in the TRC and click Next. On the next screen, I'm offered the list of configured injectors. An injector simulates users accessing the system from the location where it is physically located. Injectors allow load to be generated from anywhere, inside and outside the corporate firewall. As I want load to be generated from both London and Boston, I will select those injectors. Now I need to decide whether I want load to be distributed equally between the selected locations or whether it's to be distributed unequally. Because I know there are more users at the Boston office than there are in London, I will select to configure the load for each separately. The next screen allows me to define the number of simulated users that should exercise the system as the test starts and the number when peak load is achieved. I want 100 users at the start and 500 users at peak load. I now define the distribution of user load by configuring the percentage of users at each location. I know that 80% of the users are in Boston, so I enter 80% for the Boston location and 20% for London. It should be noted that the Next button on this screen will not be enabled until you have entered all percentages and exited the last field. We can see that the wizard has calculated the initial and total number of users for each location, based upon the percentages I specified. If I wanted to tune these values, I could click the Switch to Absolute Values hyperlink and enter the required values manually. I now have to define the user community to be used for this configuration. A user community defines the browsers to be simulated by the virtual users and the percentage of users assigned to each type of browser. I will choose Community WebStats 01/2014. This represents the global mix of browsers used during January 2014, as defined on the browser statistics page of the w3schools.com website. Because I chose to distribute load unequally between injectors, I now have to define the distribution by user journey at each location. First, I'm asked for the user distribution for the Boston injector. As I am configuring a ramping test, I must define how long the ramping interval will be, i.e., the test duration before peak load is reached at this location. I will choose 10 minutes. I now need to divide the Boston users between the user journeys. You can see I've configured 90% of the simulated users at Boston to execute the Browse and Buy user journey and 10% to execute the Change User Details journey. I can view a graph of the load profile at this location by clicking the View Load Profile button. The black line shows the profile for all users at this location, and the colored lines show the profile for each user journey. When I click Next, I can similarly configure the London injector. From this location, I'm going to apply the load over 15 minutes and allocate 50% of the users to each user journey. I now have to decide how I want the test to end. Selecting Run Forever means that I will have to manually stop the test using the StressTester GUI or command line facility. If I would like to run the test unattended, I can select the Run For radio button and enter a number of hours, minutes, and seconds that should elapse after peak load has been established, before the test will be stopped automatically. Please note, the time entered is after peak load has been established. I will choose to stop the test automatically after 15 minutes at peak load. You may remember that we configured the Boston injector to increase load over 10 minutes and the London one over 15 minutes. This means that peak load will be reached after 15 minutes. By setting the Run For to 15 minutes, the simulated users will therefore execute for 30 minutes in total. The next screen allows me to specify the infrastructure components I want StressTester to monitor while my test is executing. The navigation tree shows me all available monitoring configurations. Each node defines the monitoring configured for one infrastructure component. I should say here that any part of a TRC can be modified at a future date, so I may start with just a few components being monitored and add or remove components between tests. If I wish, I can start the resource monitoring before the load is applied and continue it after the test has stopped. This allows me to establish the usage of the components before simulated users are applied to the system, and to check that the component usage returns to the same level once all simulated users have stopped. The time is specified in seconds, and I have chosen to have monitoring running for 2 minutes before and after load is applied to the system. If you remember, we calculated that simulated users would be running for a total of 30 minutes, 15 minutes to allow both locations to ramp to their peak load, and then for a further 15 minutes. The whole test will therefore run for 34 minutes, the 30 minutes of users executing, and the 2 minutes of monitoring before and after this. Once I am happy with the configuration, I click Next and Finish to create and display the completed test run configuration. We can see that the wizard has created a separate line for each combination of location and user journey. The number of cycles column defines how many cycles are to be executed for that user journey at that location. A cycle count of 0 means that the simulated users should cycle continuously until the test is stopped. The wizard has calculated the interval between user increments required to reach peak load in the time required. For the line highlighted, the wizard has calculated that the initial number of users should be 72, and every 2.083 seconds, another user is added until the maximum load of 360 users is achieved for this combination of location and user journey. I can examine and modify the components that will be monitored during the test. I can also view graphs that represent the load profile defined. The first defines, for each user journey, how the load is applied throughout the performance test. The second defines how the user count is distributed by location. If required, I can view the graphs in larger, resizable windows by double-clicking on any graph. That is the end of this video tutorial. Do remember that you can alter a test run configuration between tests and change the locations, user journeys, user communities, user counts, and monitoring that will execute during the test.